Hi, I'm Herb Gross, and welcome to Lecture 24 in Gateways to Algebra, where in today's session we'll show an algebraic approach towards solving word problems. We're going to take basically the same problems we took last time and just show you how we can apply algebra to that and get the answers in a much more systematic way and with much less trial and error. And there's also another fringe benefit you get from the algebra way that you don't get from trial and error. So far we've been lucky that since we've been dealing with one dimension, that there's only one answer. In many cases, when you use trial and error, if there's more than one answer, how do you know when to stop? Whereas with the algebraic method, when we find answers, we'll also predict exactly how many answers there are. But I'll see if I can illustrate that as we go along. Let's just start with a problem very, very similar to what we were doing before. And this just says what? In fact, it's very similar to what we had before. I just changed the number so it doesn't get boring. John and Bill together have 950 marbles. John has 70 more than Bill. How many does each have? Well, you see, the way I would do a problem like this is what? John and Bill together. See, let J stand for the number that John has, B for the number that Bill has. John and Bill together comes out to be 950. It also says that John has 70 more than Bill. So what that says is, if I subtract Bill's amount from John's amount, that answer should be 70. And watch how fast we get the answer this way. What we do is what? When we add, the 1j and the 1j becomes 2j's. The b and the opposite of b drop out. 950 and 70 is 1,020. Then divide by divide by 2 to find j. That's going to be 510. Okay? And that's what? 70 more? Then, see, can we check this? If j is 510, how many does Bill have? Well, Bill has 70 less. So subtract 70 from the 510, that would be 440. And the 440 and the 510 would be 950. Now again, there's even more than one way to do this problem algebraically. You might say, okay, John's amount is 70 more than Bill's amount. In other words, instead of saying j minus b is 70, you might have said that j is equal to b plus 70. You also know that j plus b has to be 950. Now, as long as j is b plus 70 in this problem, that means what? Every place you see a j, you can replace it by b plus 70. That gives you down to what? b plus 70 plus b equals 950. We can add in any order we want. 1b and 1b is 2b. 2b plus 70 is 950. If 2b plus 70 is 950, if I now subtract 70 from both sides, 2b would be 880. Now divide both sides by 2, so b would now be 440. But John is what? b plus 70. 440 plus 70 is 510. Therefore, John has 510 marbles, and Bill has 440 marbles, a result that we saw another way before. Let's look at another problem, quite different. It says the length of a rectangle is 3 inches longer than twice its width. If the perimeter of the rectangle is 54 inches, what is the length of the rectangle? Now there's a few things we have to know. We have to know what perimeter means. Well, the perimeter is the distance around. If I add the length and the width and double it, that would be the perimeter. So I can write that as twice the length plus the width, or I can say it's what? Twice the length plus twice the width. Now the reading comprehension comes in. See, what are the two variables here? The length and the width. 2 degrees of freedom, 2 dimensions. I need 2 conditions. What am I told? I'm told the perimeter is 54. That means every place I see p, I can replace that by 54 in this problem. Now the other one's a little bit trickier. I need reading comprehension here. It says the length is 3 inches longer. That's 3 more than what? Twice the width. So if w stands for the width, twice the width would be 2w, and 3 more than that would be 2w plus 3. So what I can now do is what? Every place I see an L, I can replace that by what? 2w plus 3. So if I replace p by 54 here, and L by 2w plus 3, what do I wind up with? 54 is twice. Now what's in the parentheses? 2w plus 3 plus w. Now remember, w is the same as 1w. 2w and 1w is 3w. So I have what? 3w plus 3 inside the parentheses. And now the amazing thing is what? I'm back to a lesson 1 type of problem. How do I solve this problem? To unblock the parentheses, well, I can do it 2 ways. One is I can unblock the parentheses by dividing both sides by 2. As I read down my card here, I see I've opted to do it a different way. I've elected to use the distributive property. The 2 is going to multiply the 3w to give me 6w. Then the 2 multiplies the 3 to give me 6. Now I have 54 equals 6w plus 6. To unblock the parentheses here, I'm going to get rid of adding 6, so I subtract 6 from both sides. That tells me 48 is 6w. Now to find w by itself, I have to get rid of the 6. The 6 is multiplying the w, so I divide both sides by 6. I get that w is 8. Now, that's the width. The width is 8. What's the length? It's 3 more than twice the width. If the width is 8, twice the width is 16, right? Plus 3. If the width is 8, yeah, twice the width is 8, times 2 is 16, plus 3 is 19. So the width is 8 inches, and the length is 19 inches. Let's check it out. If that's the case, 8 inches plus 19 inches is 27 inches. 27 and 27 more is 54, so that checks out with the perimeter. And 19 is 3 more than twice 8. So we've solved that problem too. By the way, what's really interesting is as the wording becomes more and more complicated, the need to systematically approach the problem becomes greater. See, the reading comprehension is, I would say, equally as important as your mathematical skills. Because what good is the mathematical skills if you read the problem incorrectly? You see, the only thing worse than the wrong answer to the right problem is the right answer to the wrong problem. So we might just as well make sure we can read carefully. And here's one that sounds a little bit more like a tongue twister, I think. John is now 3 times as old as Bill. That part's not the tongue twister yet. 7 years from now, he'll only be twice as old. How old is Bill now? You see what the tongue twister is here? We have to relate now to 7 years from now. Now, let's see what the problem says. John is now 3 times as old as Bill. That's a statement that's true now. So let's take a look at this. We want to know how old Bill is now. Let's use B and J to stand for their ages now. Bill's age now will be B. John's age now will be J. Now, if John's age now is J, how old is he going to be in 7 years? Just add 7 years on to whatever age he is now. So if he was 6 now, he'd be 13. Well, we don't know how old he is now. It's just J. We add 7 on to J. That's written as J plus 7. In other words, if J stands for John's age now, J plus 7 stands for John's age in 7 years. In a similar way, if B stands for Bill's age now, then B plus 7 stands for Bill's age 7 years from now, because you just add on what? In 7 years, you're going to be 7 years older. You add on 7 to your present age. Now we have to distinguish between now and 7 years from now. It says John is now 3 times as old as Bill. That's true now. So Bill's age now, B, multiplied by 3, gives you John's age, which is J. It says 7 years from now, he'll only be twice as old. Well, 7 years from now, his age is going to be J plus 7. Bill's age is going to be B plus 7. What's the thing that's being doubled? It's not B, it's Bill's age 7 years from now, which is Bill plus 7, B plus 7. So in other words, your 2 equations are what? J equals 3 times B, and the second equation is J plus 7 equals twice B plus 7. And the way we're going to solve this is, the first equation tells us what? Every place we see a J, we can replace it by 3B. I'm going to review that sort of in words for you. See, in other words, if you have trouble with the algebra, write the words out. Say John's age now equals 3 times Bill's age now. John's age in 7 years is going to be twice Bill's age in 7 years. Then you say, okay, John's age now is J, okay? Bill's age, so John's age now is J, so John's age in 7 years is J plus 3, and Bill's age is B plus 7. In other words, you can arrive at this the same way we were doing before. But the important thing is we now say what? That J plus 7, and what can we replace J by? 3B. So 3B plus 7 is what? 2 times B plus 2 times 7. So 3b plus 7 equals 2b plus 14. How do we solve this linear equation? We first subtract, well, first of all, we can get all the numbers onto one side, all the letters on the other side. We can first start by subtracting 7 from both sides. So 3b is equal to 2b plus 7. Okay? Then we can subtract 2b from both sides, leaving us with b equals 7. And since j equals 3b, j must be 21. So in other words, Bill is now 7 and John is 21. Let's check it out. If Bill is 7 and John is 21, in 7 years, Bill is going to be 14 and John is going to be 28. And 28 is indeed twice 14. Now, is it possible that you had trouble with the algebra here? It's possible. I hope you didn't, but it's possible. All I want to re-emphasize is if you did, don't let that be enough of the reason for not solving the problem. Let's go back and review what we did in the previous lecture by doing this problem by trial and error. See, what do we know? Bill's age could be anything, 0, 1, 2, 3. We just keep on going this way. What do we know about John's age? John's age is 3 times as much. So in other words, whatever Bill is, the J column will be 3 times that. See what we've done here? See, 0, 1, 2, 3, 4, 5. The J column is 0, 3, 6, 9, 12, 15, etc. Now, what's going to happen 7 years from now? 7 years from now, Bill is going to be 7 more than he is now. So all you do is add on 7 to every number in the first column to get b plus 7. So when if Bill is now 0 years old, in 7 years he's going to be 7. If he's 1 year old, in 7 years he's going to be 8. If he's 2 years old, in 7 years he's going to be 9, etc., etc., etc. So the b plus 7 column reads what? 7, 8, 9, 10, 11, 12, 13, etc. And what about the j plus 7 column? 7 years from now, we just add 7 onto John's present age to find his age 7 years from now. 0 plus 7 is 7, 3 plus 7 is 10, 6 plus 7 is 13, 9 plus 7 is 16, etc. Now, all of these are correct. What is the piece of information we haven't used yet? The piece of information we haven't used yet is that 7 years from now, John's age has to be twice Bill's age. We come down this column, and the only place where we find that John's age 7 years from now will be twice Bill's age is when Bill's age is 14 and John's age is 21. Therefore, have we also found the answer through trial and error. The real difference is that with the trial and error chart, we can say, I wonder if there's some more and we missed them. But you see, the algebra way shows what? That Bill had to be 7 and that John had to be 21. By the way, there is a little bit of a cross between trial and error and algebra. Sometimes people are afraid of the x's, but they're not afraid of certain geometric patterns. See, what we could have done was something like this. We could have taken a little box and said, let that box be Bill's present age. Now, what's John's present age? Isn't that 3 times as much as Bill's? So if Bill's age is represented by a box, John's age is going to be represented by what? 3 boxes. Now, suppose each of these lines represents 1 year. 7 years from now, Bill's age will be what? The box plus 7 years. How old will John's age be in 7 years? Well, he's already 3 boxes, and it'll also be what? 7 years, 7 little marks over here. Now, what do we know? What we know is that whatever John's age is 7 years from now, represented by this picture, it's going to be what? Twice what you see over here. So in terms of a picture, what we're going to do is we're going to copy this down, put an equal sign in, and then copy this down twice. In other words, what the picture is going to look like is this is what? This is John's age 7 years from now. This is Bill's age 7 years from now. And since John's age is twice Bill's age, we have to write Bill's age down twice. Now this is like a seesaw balancing. I can cancel off what? I can cancel off a box on this side if I cancel off a box on this side. I can cancel off one more box here if I cancel off one more box here. I can't cancel off any more boxes because there's one on this side, but none on this side. Are there 7 lines I can cancel out here with 7 lines over here? And what's left when I do this? On the left-hand side is left a box. On the right-hand side, there are 7 tally marks, so evidently the value of the box is 7. Do you get the idea? I'm not telling you which is the right way to do it. I will tell you that if one of these ways, one of these three ways is easier than the other, do it the easier way and then keep re-examining the other two ways. Once you have one way of doing something, the pressure is off and it sort of becomes easier to see what the other methods are like. But don't be panicked if one method seems easier to you than other methods, but that's the way minds work. Some people will find one way easier, some will find other ways easier. We'll just keep on practicing until time runs out for our class, okay? Let's do another one here. This one says that Mary has twice as much money as Jane. Here's the tongue twisters again. If Mary had $4 more and Jane had $3 less, Mary would then have 4 times as much money as Jane. How much money does Jane have, okay? See, okay, so what do we know so far? It says, how much money does Jane have? Wouldn't that be nice to let J stand for the amount of money Jane has? And let M stand for the amount of money Mary has. Now, what's true right now? The amount Mary has is twice the amount Jane has. So one of our equations will be M equals 2J. And what that's going to tell us is, wherever we see M in any equation in this problem, we can always replace it by 2J. Now, the second one's a little bit more tricky. The second one says, if Mary had $4 more, well, if she has M dollars, 4 more would be M plus 4. And so if Jane had 3 less, well, Jane has J, 3 less would be J minus 3. What's the relationship now? It says if Mary had $4 more and Jane had $3 less, then Mary would have 4 times as much money as Jane. In other words, the amount of money Mary then had would be 4 times the amount of money Jane then had. You see, what happens here is that the second relationship, the 4 times as much, refers to what happens after Mary has 4 more dollars and Jane has 3 less dollars. See, the amount of money Mary would have if she had 4 more dollars is 4 times as much money as Jane would have had if she had 3 less dollars. So how is this thing going to work over here? Every place we see an M, we can replace that by 2J. So the M is going to be replaced by 2J over here. And what will that give us? 2J plus 4 is 4 times J minus 3. Once we're down to here, the word problem is all over. Now all we got to do is what? Clear the parentheses. This gives us what? 4J. 4 times 3 is 12, so it's 4J minus 12. Now we can subtract 2J's from both sides. That leaves me with J equals 2J minus 12. Now I can add 12 to both sides. That leaves me with 16 equals 2J. Now to find J by itself, I can divide by 2. And that tells me that J is equal to 8. So if Jane has $8, Mary has what? Twice as much as Jane, so she would have 16. Now, what was the condition? If Mary had $4 more, that would be $20. If Jane had $3 less, that would be $5. And it says what? That Mary would have 4 times as much as Jane. Isn't $20 divided by $5 equal to 4? You see how we solved that particular problem? There's all kinds of problems that we can do this way. Here's one with 3 variables. A piece of string, 45 inches long, is cut into 3 pieces. The second piece is twice as long as the first piece. And the third piece is 5 inches longer than the second piece. How long is the first piece? Well, let F be the first piece, S be the second piece, and T be the third piece. If I add all these pieces up, the answer is 45. That's one piece of information. What's the other piece of information I have? It tells me that the second piece is twice as long as the first. All that says is S equals 2F, or if I wanted to, I could say what? Divide both sides by 2, and F would be S over 2. And the third piece, that's T, is 5 inches longer than the second piece. That says T is equal to 5 plus S. Therefore, do I now have 3 equations with 3 unknowns? Yeah. And can I find out how long the second piece is now? You see, what's going to happen is the first piece can be replaced by S over 2. The third piece can be replaced by S plus 5. So F plus S plus T is S over 2 plus S plus 5 plus S. That has to equal 45. If I don't like fractions, all I have to do is multiply both sides by 2. That cancels the 2's over here, multiplies each of these by 2. That says S plus 2S plus 10 plus 2S is 90. Now I combine all the S terms. 1s, 2s, and 2s, that's 5s, plus 10 is 90. Subtract 10 from both sides, 5s is 80, so the length of the second piece is 16. By the way, the first piece is half of the second piece, so if the second piece is 16, the first piece must be 8. And since the third piece is 5 more than the second piece, the third piece must be 21. And let's check this out. 8 plus 16 is 24, plus 21 is 45. That adds up okay. So the first piece must be what? 8 inches long. Okay? By the way, the problem sometimes can be worded subtly different, and again, you have to worry about the reading comprehension. Here's one that says a piece of string 45 inches long is cut into 3 pieces. The second piece is twice as long as the first piece, and the third piece is 5 inches longer than the first piece. How long is the first piece? This sounds almost like the first problem, the problem we just did, only in the other problem it says what? The third piece is 5 inches longer than the second piece. See, I have to read what's being modified here. See, in this problem, f plus s plus t is still 45. S is still twice f. But now, t is no longer 5 plus s, it's 5 plus f. So now when I add f plus s plus t, I can replace s by 2f. I can replace t by 5 plus f. This becomes f plus 2f plus 5 plus f equals 45. I don't need the parentheses there. The 1f plus 2f plus f gives me 4f, plus 5 is 45. Subtract 5 from both sides, so 4f is 40. And if 4f is 40, f must be 10. So now the first piece is 10. The second piece is twice as long. That would make it 20. The third piece is 5 inches longer than the first piece. That would make the third piece 15. And notice again now, that one change in wording makes the length of the 3 pieces 10, 20, and 15. And that's quite a different answer than what we had before. By the way, sometimes we have problems that get even more complicated in terms of trying to keep track of things. Let's conclude with one more example, say. It says 3 apples and 4 pears cost $1.16. At the same time, 5 apples and 7 pears cost $2. How much does each apple cost? We're assuming that the apples are all equally priced and the pears are all equally priced. You're buying them by the piece, not by the pound. It says, how much does each apple cost? Aren't there 2 variables here, the apples and the pears? So A will be the cost of each apple in cents, and P will be the cost of each pear. So if I'm buying 3 apples at A cents each and 4 pears at P cents each, the total cost is going to be what? 3A plus 4P. And what's the total cost? It's $1.16, which in cents is 116 cents. See, if I take the 5 apples, see, what's the cost of each apple? It's A cents. I'm buying 5 of them, so 5A is the cost there. Each pear costs P cents. I'm buying 7 of them. That's 7P. So 5A plus 7P has to equal 200. Now, don't I have again here 2 equations and 2 unknowns? The only difference is that now the 2 equations and 2 unknowns came from a bona fide word problem. The technique for solving these equations is the same as what it was before. See, once I have the equation, I can decide to get rid of the p's over here because I want to find out how much each apple costs. Well, to get rid of the p's, this is a 4, this is a 7, the common denominator is 28. I'll multiply the top equation by 7 and the bottom equation by 4, actually by -4, so I can get things to drop out by addition. See what's going to happen? The top equation becomes 21A plus 28P equals 812. So just multiplying by 7. Bottom equation, multiplying by -4, gives me -20A plus -28P equals -800. Now when I add, the 21A and the -20A comes out to A. The 28P and the -28P cancel. 812 plus -800 is 12. And lo and behold, I've got what? That each apple costs 12 cents. By the way, it didn't ask me to find out how much the pears cost, but if each apple costs 12 cents, 12 times 3 is 36. So 36 plus 4P would have to be 116. I would then subtract 36 from both sides, get that 4P is 80, hence P would be 20. So the apples would cost 12 cents each, and the pears would cost 20 cents each. Now, we could do many more problems, and we will in the study guide eventually, but for now what I want you to see is what? The importance of reading comprehension. the importance that even if you can't do the problem by algebra, to at least be able to do the problem by what? Trial and error using a common sense method. And what we see is what? That once we have the reading comprehension that allows us to translate the word problem into an algebraic equation, we solve the equation in exactly the same way as we did before we were doing word problems. That part doesn't change. At any rate, this ends one particular phase of our course. Next time I'm going to start a new thing called polynomials, but until next time, have fun, stay young, study hard. See you next time.